All right, ladies and gents, this is BC Calc section 2.1, definition of a derivative. Your homework is to the right, page 103 in those 6 problems. We're going to find the slope of the tangent line to a curve at a point. We're going to use the limit definition to find the derivative of a function. You guys probably will remember this from last year. You had a little bit probably on the AP test, not much. We're not going to see much this year either, but that's okay. So the derivative of a function allows you to find the slope of a function at a point. So any point on the graph, that is what a derivative tells you. As long as it's at that point, it'll tell you the slope of the function at that point. The derivative of f is given by, so there are a couple different ways we can write it. One, you'll realize and probably remember from last year that there are 2 ways to write it. One is going to change a little bit just because of the way I'm going to write it, but it's pretty much going to be the very same thing. So the limit as h approaches 0 of f of x plus h minus f of x over h. So this is one from last year we talked about, very similar. The other one that we could potentially use is the limit of delta x as it approaches 0 of f of x plus delta x minus f of x over delta x. Now delta, if you remember hopefully from science classes, delta means change, so the change in x. The other one we talked about was as x approaches c, and c is that value that we're trying to, that's like that change, right? We're changing from x to c, and that's where the delta x is coming from. So this is provided the limit exists. For all x for which this limit exists, f prime is a function of x. Okay, that's kind of what we're saying. Pretty simple, self-explanatory. Let's move on. There are 5 different ways to write the derivative. You've seen most of these already. F prime of x makes sense. Okay, remember this is prime, not f apostrophe, it's f prime. Another one is dy over dx. Remember this was Leibniz and Newton they were like fighting over like who was gonna like have all this stuff, and it really doesn't matter. The other one we got y prime. The fourth one is we can say it's d over dx and then with kind of f of x next to it. That's another way of saying find the derivative of x with respect to x. And then the very last one, this one's probably very different and not many we will see this year, but is the derivative with respect to x of whatever we're finding. Alright. Fantastic. So with that being said, let's get into some examples on how we find the derivative using the definition of the derivative and not using the power rule, which is what you guys want to do. Because remember last year you had your whole unit 2 was over this kind of stuff, secant lines, definition of derivative, things like that. And then when you got to unit 3, you're like, why couldn't we do this then? Well, again, I just want to refresh some of that stuff from last year so we can kind of get better at derivatives and all of that understanding of that stuff, so we can move on to the new stuff and be very good at that as well. So again, I'm going to find the derivative of this. So this is a limit as h approaches 0 of f of x plus h minus f of x over h. Okay, here we go. Then I'm going to say it's the limit as h approaches 0. You can see that I'm carrying down my limits all the time. I'm going to use my function and plug x plus h into x. So it's x plus h minus f of x, which this is really just 2x minus 3, right? O'Reilly Auto Parts, I made a mistake. This should be 2 times x plus h minus 3 minus, and then 2x plus 3. I basically put the negative and I distributed already, so I did that kind of in my mind. Over h, then I got the limit as h approaches 0 of 2x plus 2h minus 3 minus 2x plus 3 over h. Now you can see that stuff is probably going to cancel. The 2x's are going to cancel, the 3's are going to cancel. So I get 2h over h, which is equal to 2, because the h's are going to cancel, and that's a constant. The limit of a constant is always the constant. Alright, so therefore the derivative of f is equal to 2, and it tells me the answer should be 2 because the slope is 2. Now this was a linear function, that's why you can tell already. And the reason why it's 2, because if I graph this line, it's going to look something like this, and no matter what point you are on that line, okay, no matter what point, the slope is always going to be 2 because it is a linear function, and linear is always straight. Fantastic. Great and good to know. This one's going to be a little more complicated, but we're going to do it. So I want to find the derivative of this. Okay, limit as h approaches 0 of x plus h to the third plus 2 times x plus h minus x to the 3 minus 2x. I just flipped the sign already because I subtracted them over h. Then let's kind of go from there. There we go. When I do this to the third power, I get x to the third plus 3x squared h plus 3x h squared plus h to the third. Ugh, that's Pascal's triangle if you remember. 1, 3, 3, 1. That's the fourth one down. Plus 2x plus 2h minus x to the third minus 2x. All of that's over h. Still got the limit as it is approaching 0. Now I can cancel some things out, right? So x to the thirds are gone, 2x's are gone, and everything else has an h in it, so that's great. 3x squared h plus 3x h squared plus h to the third plus 2h, and all of that's over h. Cancel the h's out, so I get limit as h approaches 0. Oh, and my throat's a little parched. I've been talking too much. It's 1:15 in the morning here. Okay, so cancel the h's, so I get 3x squared plus 3xh plus h squared plus 2. My denominator h is gone. Now, what's actually happening is I'm plugging the 0 into all of the h's because I got rid of my denominator, so now I can plug the 0 in. So this is still now equal to, how do I want to write this? We'll just write it this way. So because I plugged the 0 in, this goes to 0, this goes to 0, so I get 3x squared plus 2, which is equal to f prime of x. Therefore, the slope of the function, okay, the slope of the function f is f prime, and the value of this slope changes with whatever your x value is. So this is your slope of the tangent line, but it says find the equation of the tangent line through that point. So I have to use this now to determine what the slope is of that point, or of that line through that point. So I'm going to use my x and I'm going to plug that in. So I'm going to say it's f prime of 2 is equal to 3 times 2 squared plus 2. So this is 3 times 4 is 12 plus 2 is 14. Now I'm going to use point slope form. So I get y minus 12 equals 14 times x minus 2. And that is an equation of your tangent line. Remember, we didn't really talk about tangent lines yet, but a tangent line is what touches the graph at one point. So this right here, right, is what? It's going to look like something like that, okay? And at 212, way up here, actually I don't even know where it's going to be, but maybe up here, it's going to be slope of 14, so it's going to be a very, very, very steep slope, okay? Great, great, great. I think that's it. That's all I need to talk about there. Fantastic. Let's go on to the next part here, and we're almost done. Here's the alternate definition of a derivative. This is what we did last year. This is one of our 2 definitions of the derivative. Okay, so an alternate definition is this. So f prime at c, so f prime of the value that you're trying to find is equal to the limit as x approaches that value of the original function minus the value plugged in over x minus that value that you're trying to find it at. So this definition is based on the formula for slope. Okay, right? For slope, y2 minus y1. Okay, the derivative is calculated, is the calculated slope between 2 points that are infinite. I can never get this word right, ever. Infinitesimally close together. Infinitesimally, I don't know how to. I need to like hooked on phonics or something. I can never get that word correctly, and all my years of saying it, I never get it right. I don't know. Go to Google and type it in. I probably should do that too. The existence of this alternative form requires that the one-sided limits are equal. So the c from the left and from the right are equal. Otherwise, if they're not equal, then there's no derivative at that point. Okay? Let's see what else we got. That's it. That wasn't so bad. That's pretty easy. Dang, this is BC is really easy, huh? Alright, I'll see you in the next one. Deuces.